Hey guys, what's up? Eddie Yahoo here with KissAnalog.com. Guys, I've been doing a series of videos on interconnects. Do they make a difference? Do cables make a difference? Now, I've talked about, where is it? All right, so I've talked about power cables, right? I'm going to put a link for this one. This one, checks a lot of boxes, okay? But it's only about 50 bucks. So if you got to have a nice power cable that looks great, there you go. Oh, this is some Kimber speaker cable. Yeah, we haven't talked about this one yet. So, this stuff's fairly expensive too. I was just looking it up. I'm not sure. I have to look. It's got gold. Yeah, I'll have to check on that. It's, a couple $100, I think, $200 or $300, something like that. But I've tested interconnects, these IXOS cables. Here's another set. Different types, the braided or the coax type. And then I tested a bunch of monster cables. Well, not a bunch, couple. Had this monster cable, okay? And then I had this red one. And I bought this cable here, RG400, I believe it is. Super nice cable. It was like $5. I'm going to put links down below, okay? If you want to buy some cables, please use the links. Support the channel. Appreciate it. I made my own interconnect cable with a speaker wire, 18 gauge zip cord. Tests pretty darn nice. And then, I've got Kimber cable in here right now, okay? And the Kimber cable, it's Silver Streak. This stuff, it depends on the length. This one's 1 meter. I think this is around $600-700 for a pair of these. And I just realized I had another pair, 1/2 meter. So a little bit less, 400 or 500, something like that. And this is a IXOS cable, okay? So I've done a lot of cables, but what I got for you today is the world's best cable. All right, do you believe it? And the price is pretty good too. Here it is, world's best cable, it says right there. Now, the thing is it does have Amphenol connectors. So Amphenol is a company that makes connectors for a lot of military applications and things like that because they're been around for a long time. They make great connectors. So they're using Amphenol connectors, Mogami cable. You guys probably heard of Mogami. So we're going to test these bad boys out. All right. Now, here's the thing about this. It's going to take a while. Because I need 175 hours to burn them in. Please allow 175 hours of burn-in time for optimal performance. This burn-in does not have to be a continuous process. You may pause burn-in and continue when possible. I guess you just have to get the hours on the cables, right? And then there's 3 things. You can return them, okay? If you don't like the cable after the 175 burn-in time, you have passed the Amazon return window. See, that's the... But, they're trying to cover it. They're saying Amazon refuses to accept, then please send them a message and they'll see what they can do to help you. All right? So, yeah. Burn-in time. They got to be the world's best cable. 175 hours. So, there you go. All right? Now, the Silver Streak, the Kimber cable, these things, they have, let's see, 3 strands they braid. One of them is silver wire. So it's actual silver, right? And they give some specifications on the back, capacitance, inductance, that kind of thing, okay? Now, I've tested these things in different ways. I've tested the loop, the loop gain, basically the impedance over the audio band. I went way past the audio band too, just to check and compare the impedance of all these cables, plus a bunch of other coax cables and things like that. So, and then I did a test where I wrapped them up and tried to induce some noise using my IT7321. This is an AC power supply from iTech. Very nice power supply. It has a dimmer function where it'll simulate the dimmer function where you get sharp edges. So wherever you get sharp edges, you're going to get harmonics and stuff. Okay. So I wrapped that noisy cable. I'm kind of simulating, what if you split your power cable in two, took one of them and wrapped your interconnect around it? What if you did that? Kind of a worst case scenario, but hey, you know, you might want to try to induce some 60 hertz hum. So I did that. I used the dimmer function to put some extra noise on it. And I'm only using about 1.6 watts here. So the signal is small. So if there's any distortion at all, it'll look bigger compared to the signal, right? If I put a larger, you know, signal like 100 watts, then the noise, you know, the signal is going to go up and the noise is right here. So if I bring it down to 1.6 watts, I was going to hit 1 watt, but I just hit 1.6. But right there, then, you know, so yeah, I'm doing the worst case scenario. So I did another video where I actually showed there's some difference. You know, you can get some noise. Somebody told me, yeah, but you can hear millivolts, but the noise was in the microvolts. So anyway, yeah, check out that video. I'll put the link down below, and maybe then this video I'll try to make it where you can click on it. Okay, so I bought the world's best cable just for you guys. It does have gold ends on it, and these things make very nice connections. It's kind of a spiral thing. I'll show you a little close-up of this. But yeah, so there you go, guys. Let's get in testing. Let's compare it. We're going to compare it to this Kimber, okay? I've done a bunch of testing. You can go back and look at the other tests, but now I want to test the world's best cable, all right? So let's do it. All right, guys, so there is our signal. Now, the signal, this is a signal that's coming out of the Quant Asylum. Nice, clean signal. And this is a signal coming out of the IEMA. And this is a clean signal too, although it does have stuff down here. But it's about 1.6 watts. Now, if you look up here at the top, see THD is 0.00514. So very low. The THD plus noise is 0.0074, which is very low. So here's the 1 kilohertz signal. It's 11.29 dB, so that's about 1.6 watts, somewhere around there. And here's the harmonics, the third harmonic, the fifth, the seventh. So they're all down here. Like this is minus 75, right? Yeah, that's minus 75 dB. So that's very low, okay? This is like 100 microvolts, I think, minus 80 dB. So 1 volt is here, 0. Minus 20 is 100 millivolts. Minus 40 is 10 millivolts. Minus 60 is 1 millivolt. And so this is 100 microvolts, okay? So 100 microvolts, so it's just above that. And the other ones are below 100 microvolts. So that, and 10 microvolts is down here at 100 dB, minus 100 dB. So you see the even harmonics down here too. And then the noise floor is way down here, close to 110 dB, minus 110. So pretty close down here, okay? Here's a 60 hertz from power line type stuff, and it's minus 90, so it's way down here, okay? And there's 120 hertz, the harmonic of 60. So, all right, guys, now what I got to tell you is I put my 18 gauge interconnect I made in here. So I'm going to take it out and swap it into the Mogami, okay? So, but before I do that, I want to twist this up with the red wire just to show you how much noise it gets coupled in, okay? So first we'll stop this. I'm going to save it. All right, guys, I twisted the red wire around my homemade interconnect, 18 gauge wire. Okay, now I'm going to go ahead and turn on the dimmer power supply, and let's see what kind of noise we get on that, okay? All right, guys, I'm going to switch it on right now. Here we go. Got about 48 watts almost, and you see the noise kind of jump up here, but still, remember, minus 80, 100 microvolts. So 10 microvolts here. So it's like, I don't know what that is. It's 20 microvolts or something. Very, I mean, you see the noise, but it's really low down here. 84 dB signal noise. Now, see those numbers up there? See if they change when I turn it off, because this right here includes the noise, and that one might drop the one. This one shouldn't really be changing, and the signal noise. So let's take a look, okay? All right, guys, so keep an eye on it. Let's see what happens. Now, this recalibrates. This was 0.78. Now it's, well, this guy was 0078. Now it's 007. So, yeah, this digit down here, way down here, changed. But, guys, that's how low this noise is. And we're doing our best to couple noise. Okay, so let me go ahead and freeze this, and I'll change out the cable to the Mogami. All right, guys, my homemade interconnect using the 18 gauge wire here, okay? It is twisted up with the red one, and there's the resistor. So we're trying to conduct some noise into, or induce some noise, I guess I should say, you know, magnetically couple, electrically couple noise into this cable. All right, so took one wire, the return wire is right here, so we just took one wire, we separated the power cable, which is abnormal, which you would not get in behind your cabinet, right? They'd be tied together like that, right? Zip cord. But anyway, separate just so I could try to couple some noise. And so now, before I did that, I first tested this without the red wire twisted or anything, just hanging out here. So we're going to put the Mogami on. All right, guys, here is the label just so you can see what it looks like. And the other side of it. All right. And here is the cable I took out of it. And you can see how nice these connectors look on the back side, right? Looks like they have a nice design to them, right? Okay, world's best cable. So let's see what it says there on the side. It says high definition audio video cable. It's a 2964 Mogami number there. All right, so let's go ahead and hook it up, and what we're going to do is we're going to hook it on the output. I guess we'll take one of them, hook it on the output of this guy, take it over to the input of the amplifier. We'll test one channel, okay? And then after that, we'll get a reference here on my screen, okay? And then what we'll do is we'll hook up the red wire. See, up there, the power supply has this AC power cord coming down, and then it breaks off into these two wires, and we'll take one of them and just wrap it around. If you saw my last video, you kind of know what I'm talking about. It is a power supply is powering this 91 watt resistor, 18 ohm resistor, and so it'll get quite hot. So it sits on this silicon mat. It's 91 watts. We're putting about 47 watts in, and we get a waveform looks just like that. Very high, fast rising edge, and then a quick turn off, and we got these flat spots. And so that's the power for this, looking like a dimmer switch powering up this resistor. So yeah, pretty sharp edges, puts out some noise. And this does have a snug fit on this adapter plug, gold-plated adapter plug. So yeah, very snug, tight fit. So then I put it into the quiet sound like that. And then on the other end, I have another one of these adapter plugs, RCA to BNC. So let's put that on and do the test. Actually, on this other end, I have the RCA plug. Breaks off, goes into both channels. So I've already got a gold-plated RCA plug here. All right, we have our the world's best cable in there, the Mogami with the nice Amphenol connectors, okay? And the wire comes down here and goes over here to the back of the stereo, okay? Then here's my red wire. It's not twisted around yet. Okay, it's just, it could couple, but it's right angles. So that's best case scenario as far as coupling. I guess the best case would be if they're twisted. So let's go see what we got. All right, guys. So here's the Mogami cable. And for some reason, the ground, the 60 cycle and the 120, some of this ground noise popped up. Seems like sometimes, I don't know if it's a coincidence, but sometimes when I use a coax type cable, it seems like I get higher signals on the low frequency stuff. Not sure what's going on there, but up here we see 0.004, 0084, so very low numbers, 83 dB, so very low numbers. But yeah, I went back and forth between my handmade cable and this, and every time I put it on, I'm getting these kind of signals. So I don't think it's something turning on the house because it'd be too coincidental. Anyway, I find that interesting. I have to keep an eye on that, see if I can figure that out. I was wondering if I was touching something on my setup, moving something slightly, but I tried real carefully not to move anything or change anything except for the connections. So, not sure. All right, now I've taken the Mogami and I've twisted the red one, the full length of the red one before it goes to load. And we're going to inject that signal and see what we see. All right, so here we go. Here's a Mogami just running along, twisted. I don't think the numbers are any different than before it was twisted. But we're going to have to turn on the power now, right? Okay, so let's turn on the dimmer power supply and see what happens. I think I've seen a little bit more grass, a little bit more noise right through here, right through the 1 to 2, 3 kilohertz range. Here, let's turn it off and see if that, and up here, the THD plus noise is 0.0087. Let's see if that changes much. 0.0086. Okay, let's see if it changes. Turn it off. Maybe some of it went away, 0.00847, so it may have changed just slightly, right? But man, you see what I mean? These numbers are really small down here, and we're barely seeing any change. So I'm going to turn it back on again. Takes a couple, yeah, it has to gather data for a couple of cycles. And then there you go. And man, it's just, is it insignificant? Can you even hear this? But is this cable better than the other cables? I don't know if it is. I think my coax cable, the one I tested last time, looked pretty darn good too. So yeah. Okay, guys, let's compare it to the Kimber cable, the expensive cable, okay? All right, we're going to test the expensive Kimber cable, okay? Got it wrapped up in red. We'll do it first with no noise and then with the power supply turned on. So, yeah, very nice connectors on the Kimber cable. They tighten down so they get real snug connection. But you know what? The world's best cable had a very snug connection as well. All right, so here we are. We're running and we've got our 1 kilohertz signal. And, the harmonics are over here. The 60 hertz, 120 is kind of poking up here. And we got 0.0045, 0.0077, and then 84.6 dB. Okay, that's looking pretty good, right? Okay, let's go ahead and turn on the dimmer power supply. Oh, there it goes. So it did jump up. And you know what? I think the world's best cables beating this. The coax type cables do better through here. But look at this. The 60 hertz, 120 hertz drop down when I turn on that power supply. So that's interesting. Well, it looks like it might be climbing. It's taking samples and all that kind of stuff. So yeah, it might be kind of, all right. That's interesting, right? You have to wait a little bit, let this scan a few times. But maybe it initially knocked it down and then it had to climb back up. So I don't know where that noise comes from. It's being, it's just being picked up somewhere. So yeah, it took a few cycles for it to build up. So there we go, guys. There's the Kimber. All right, guys, so what do you think? Now, I'll put the link down below. This cable is fairly inexpensive. I think it was like 35 bucks, something like that, $30. It depends on the length. So it's made in Japan. Japan does a nice job with quality and stuff, so you're going to get some good quality cables if you like them. Or you can use a 12 gauge wire here and make yourself an interconnect. Or I'll tell you what, you can buy the silver streaks from me. Man, I'll give you a sweet deal. I got 2 pairs. Anyway, guys, hey, thanks for watching. If you liked the video, give it a like, okay? That really helps the channel a lot. Subscribe if you haven't done that. Now that I think I'm done testing these cables for a minute. We still have speaker cables to investigate, right? We're going to investigate those. I saved them for last because I really expect to find something in speaker cables. But I'm going to start testing some other amplifiers. I got a stack of them up over there by my camera. And I've got another stack somewhere. So I've got a bunch of amplifiers I got to go through, okay? I actually have a ZA3 right here. So I need to do that one. That's a big box. Maybe we'll start with that guy. So, yeah, let me know. I've got the ZA3. I've got a couple other IEMAs. I got the A70. I've got some stuff from FX Audio, which I'm really excited to test that stuff. So, what else? Yeah, I have different amplifiers and different stacks around here. I got to clean out my lab. I'm going to lower this stuff. I'm going to sell some equipment. And, yeah, I think I saw that HP, some of these power supplies. I think we'll just try to clean up the lab a little bit, okay? So, yeah, maybe I'll get rid of this guy too. You know, it's taking some space. Somebody might like it. I like to listen to this radio on it, actually. But, yeah, it's a nice Zotec bench power supply. But then I've got this nice one from Uni-T. Anyway, I better just get off. I'm just stretching out this video. The Quant Asylum QA403, very nice piece of equipment. So recommend that. If you go back and look at my other video where I did a bunch of tests and kind of showed there's some difference, these coax type, they do a really good job at the high frequencies, right? They look really clean. The Kimber, the braided type, yeah, they don't do quite as well. But then again, these signals, all these signals are so low, right? Just to remind you, 0 dB is 1 volt, and then minus 20, so every 20 dBs, it's 10 times less. So 1 volt, 100 millivolts, 20, minus 40 is 10 millivolts, and minus 60 is 1 millivolt, okay? Minus 80 is 100 microvolts. So you can see how that signal, we're down in the microvolts, hundreds of microvolts, but still microvolts, less than a millivolt. So yeah, the noise is really low. And yeah, okay, two big thumbs up to my patrons, 2 big thumbs up to my members of my channel, and Danny for being a team member. Thanks, guys. Really appreciate you guys for supporting the channel. Using the links down below supports the channel, and subscribing, big help. All right, let's get back to the video. There you go, guys. Let me know what you think of this. Give me your comments down below. And yeah, I think the world's best cables hanging in there with the rest of them. So there you go, another option. Just wanted to see what the world's best cable would do. All right, thanks for watching, guys. See you next time.